Right, so let's write equations of perpendicular lines. Right, so as a reminder, two lines are perpendicular if and only if they have slopes that are negative reciprocals. Oh, by the way, I forgot to mark which ones were in your notes, so you just be paying attention and make sure you fill in your notes. Right, so first of all, we have to identify the slope of the given equation and change it to the negative reciprocal. Right, so if your equation is not in slope-intercept form, you're going to have to put it in slope-intercept form. Right, so our equation is 6x plus 3y equals 9. Right, so the first thing we need to do is subtract 6x from both sides. And make sure you put it in front of the 9. So we have 3y is equal to 6x plus, negative 6x plus 9. Right, so now we're putting it into slope-intercept form. And then we're just going to divide both sides by 3 to isolate y. Right, so we have to divide everything by 3. Right, so the 3's will cancel here, so we have y is equal to negative 6 divided by 3, that reduces to a negative 2. And then 9 divided by 3, that's 3. Right, so the slope of the line that we're given is negative 2. So we have to change it to the negative reciprocal because we're writing the equation of the perpendicular line. Right? So our perpendicular slope, we flip it and change the sign. So instead of negative 2, it's going to be a positive 1/2. And now we're just going to use point slope to write the equation of the line. We're always given a point, right? So our line is going to go through the point 5, 3, right? We're not going to use the other equation at all now. So once we identify the slope and change it for our line, that's all we're going to do with that line. Right? All we need now is our point. Right? So to find the equation of the line that passes through the point 5, 3 and is perpendicular to the line that whose equation is 6x plus 3y equals 9, we're just going to use point slope. We're going to replace the y1 with 3. We're going to replace m with 1/2. And we're going to replace x1 with 5. Right? So now we'll distribute the 1/2. So we have y minus 3. Right? So that for the first equation we just wrote, this is point slope. So if it tells you to write the equation in point slope, and we'll always use point slope as our equation, unless we're writing the equation of a line on the graph and we can identify the y-intercept. Right? So we're going to use point slope first, right? And then we're going to simplify to have slope-intercept form too. Right? So we have y minus 3 equals, and so to rewrite this, we have to distribute the 1/2. 1/2 times x is 1/2 x. 1/2 times negative 5 is going to be negative 5/2. Right? And now all we have to do is add 3 to both sides. However, we need to make sure we have a common denominator, right? Because we're going to be adding 3 on this side, right, to negative 5/2. Right? So to be able to add them, we're going to have to change 3 so it has a denominator of 2. Right? So technically 3 has a denominator of 1. Since we have to multiply 1 by 2 to get 2, we're going to have to multiply 3 by 2, and that gives us 6. Right? And notice if we were to reduce 6 divided by 2, that would just be 3 again. Right? So instead of plus 3, we're going to change that so we can add these together to plus 6/2. Right? So now we have the equation of our line in slope-intercept form, which is y equals 1/2 x. Negative 5/2 plus positive 6/2 is going to give us 1/2. And there we go. So now that's our equation in slope-intercept form. And there we go. All right. So we're going to identify the slope of our given line, change it to the negative reciprocal for our perpendicular line. We're going to set up point slope, and then we're going to isolate our y. Right? Solve for y there, and that will give us our equation in slope-intercept form. And we're all done with this one. Let's do another one. I think I have about maybe 3 of them. And then we're going to do a multiple choice problem together. All right, so this is a reminder, two lines are perpendicular if and only if they have slopes that are negative reciprocals. So what is an equation of the line that passes through the point 2, -5 and is perpendicular to the line whose equation is y equals -2/3 x minus 4? Right, this time our equation already is in slope-intercept form. Right, so y equals -2/3 x minus 4. So we don't have to do any work to be able to find the slope, right? Our slope is just -2/3. Right, so now we need the slope of the perpendicular line. And we're just going to flip it and change the sign. So instead of -2/3, we're going to have 3/2. Right, and then we use the point that we're given for x1, y1, and now we just replace. Right, so our equation in point slope form is going to be y minus and -5 equals, and that was 3/2 times x minus 2. Right, so we'll simplify that minus a negative, so it's y plus 5 equals 3/2 times x minus 2. This would be our point slope form. And now we'll isolate y to get our slope-intercept form. And to do that, we'll need to distribute the 3/2. Right? So we have y plus 5 equals 3/2 x, and now -2 times 3/2. Right? So if you don't reduce, you just have to reduce afterwards. But if you realize, so when you multiply, you can always cross-reduce. Right? So you can reduce from numerator to denominator. Both of those numbers are divisible by 2. Right? So -2 divided by 2 is -1, and 2 divided by 2 is 1. So now I can just multiply. -1 times 3 gives us a -3. Right? So 3/2 times -2 is going to be -3. And that makes sense, because if it was 2/2, it would just be 1. And 1 times -2 is still going to be -2. Right? We have another half. Right? And so half of -2 is 1 more. Right? So we're at -3. So now we have y plus 5 equals 3/2 x, and this is going to be minus 3. And now all we have to do is subtract 5 from both sides. To isolate y, we have y equals 3/2 x minus 8, and that's in slope-intercept. Okay, so slope-intercept form. There we go. And we're all done. So that's the equation of the line in slope-intercept form that is perpendicular to that given line there and passes through the point to -5. I think we have one more. And we do. Right, so we want, just as a reminder, two lines are perpendicular if and only if they have slopes that are negative reciprocals. What's the equation of a line that passes through the point 10, -6 and is perpendicular to the line whose equation is y equals 5x minus 4? Right, so our equation is already in slope-intercept form. So we know what our slope is. The slope of the perpendicular line, actually it looks better to put the perpendicular first. We just flip it and change the sign. Right, so we're going to flip 5. Right, so technically that's the same as 5 over 1. So now we're going to have 1 over 5, but it's going to be negative. Right, so we have -1/5. Right, and so now we're just going to substitute into the point slope form our point and our slope. Right, and I'm going to switch colors. It's boring using one color. All right, so y minus a -6 equals, was that negative? Yeah, -1/5 x minus 10. Let's simplify that as double negatives. Y plus 6 equals -1/5 x. Right, so now -1/5 times -10. Right, both of those. So we can reduce right here from numerator to denominator. Right, those are both divisible by 5. 5 divided by 5 is 1, and -10 divided by 5 is -2. Right, so that's going to give us just a -2. Now, if you didn't, and actually that would be, oh, excuse me, I left a negative off this one. All right, so now that's going to be a positive 2. If you didn't reduce, you would just have negative 10, right? Because negative 1 times negative 10 would be a positive 10, excuse me. Positive 10 divided by or over 5, and that would reduce to 2, right? 10 divided by 5 is 2. All right, so whether you reduce or you don't reduce when you're multiplying, it won't matter. You'll get the exact same number. Our last step is to subtract 6 from both sides. So y is equal to negative 1/5 x minus 4. And there we go. All right, so this one here is the point slope. And this one here is the slope intercept. Right, and see, so long as you can, multiply and add and subtract, right, you're not going to make any errors going from point slope to slope intercept form, and you don't have to, the equation's all done. Let's see, is there another one? I know we have a multiple choice question for us to do. Was that my last example? Yes, it was. So now let's do a multiple choice question. All right, so 2 lines are represented by the given equations. What would be the best statement to describe these 2 lines? All right, so on the Nearpod, you'll have some multiple choice questions. I decided that I would do the most complicated one. All right, so if we're given 2 equations and we're asked about their relationship, the first thing we always have to do is to put the equations into slope-intercept form, if they're not already in slope-intercept form. So in other words, we have to isolate, the y. I'm thinking y, and I wrote that instead of a t for isolate. Isolate y. Right? Right, so let's look at our first equation here. All right, so we have 2x plus 5y equals 15. We're going to subtract 2x from both sides. So we have 5y equals negative 2x plus 15. All right, so now to isolate y, all we have to do is divide everything by 5. So that would be y is equal to negative 2/5 x plus 3. All right, so now let's look at the other equation. We have to do just a little bit more work to isolate y, but that's okay. So to isolate y, we're first of all going to have to distribute that 5 until we get rid of the parentheses. We can't do anything else. All right, so 5 times x is 5x. 5 times 1 is 5. Right, and then we have negative 2y plus 20. All right, so we have 2 choices. Either we're going to move the y to the left-hand side, right, and then move everything else and the 20 to the right-hand side, and then, leave the 20 where it is. Let me say that again. So either we're going to move the negative 2y to the left, and the 5x and the 5 to the right, or we leave the 5x and the 5 where they are and move the 20 to the left side. Let's just isolate the y on the right-hand side. Nobody says the y's got to be on the left. Right, so just a little less work. If we subtract 20, right, we'll move that term over and then isolate y on the left-hand side, or the right-hand side. All right, so we have 5x, 5 minus 20, that's going to be a negative 15, equals negative 2y. All right, so now to isolate y, we're going to have to divide everything by negative 2. So that's going to give us negative 5 halves x, and then those 2 negatives will cancel. That's a positive 15 halves. Right, that won't reduce any further, equals y. All right, so now let's take a look at both of the slopes. All right, so for the line on the left there, y equals negative 2/5 x plus 3. Our slope is negative 2/5. Let's look at the slope for the equation on the right. I'm just going to read it backwards. Y equals negative 5 halves x plus 15 halves. If it's really bothering you, by the way, you can switch the side that they're on. Right? So I can switch and put the y on the left-hand side and everything else on the right. Right? So y equals negative 5 halves x plus 15 halves. right? Exact same equation. All right, so here our slope is -5/2. All right, so let's look at our choices here. The lines are parallel. Well, that's obviously wrong, right? Because they're not the same slope. -2/5 is not equal to -5/2, right? So that is wrong. No, so by the way, after we put the equations into slope-intercept form and isolate y, you're going to identify the slope, which we already did, and then determine the relationship. And that's what we're doing now. I went right to the doing, and I didn't write it down. Sorry about that. All right, so they are definitely not parallel. The lines are the same line. All right, so for parallel lines, we have the same slope. Now, I didn't put this one in your notes, but it would not be a bad one to write down so that when you're solving problems, you have a sample. So parallel lines have the same slope. Lines that are the same line, they're also called coinciding. So to coincide means it's right on top of it. It's right in the same place, right? So coinciding lines are essentially two equations that if we simplify them would be the exact same equation. So they have the same, so parallel lines have the same slope and different, but add this, different y-intercepts, as opposed to coinciding or same line where it's the same slope and the same y-intercept. Well, if they don't have the same slope, they're not going to be parallel or the same line. Lines are perpendicular. So we know that perpendicular lines have slopes that are negative reciprocals. All right, well, -2/5 and -5/2, they are reciprocals, but is either one of those positive? No, not at all. Both negative. Right? And if you wanted to be even to check it, you can even graph it, and you'll see that they are definitely not perpendicular lines. Right? They are. They're just going to be our last choice. So if two lines are not parallel, not the same line, and not perpendicular, everything else is intersecting. So the lines intersect at an angle other than 90 degrees. So anytime you're not parallel, you're not the same line, you're not perpendicular lines, you have to be intersecting lines. Right? And when you intersect, it's not going to be at 90 degrees, because if you intersected at 90 degrees, you'd be perpendicular, and your slopes would be negative reciprocals, and they're not. All right, so make sure whenever you're solving a problem like this, make sure you isolate y, you put it in a slope-intercept form, you identify your slope, and then you determine the relationship. Right? I didn't put this one in the notes, but I should have. Right? And I'm strongly suggesting that you pause the tape now and maybe add these to your notes. Right? So bye for now.